Welcome. Today we're diving into why statistics is absolutely essential in the world of data science. Whether you're just starting out or already working with data, understanding statistics is the foundation for making sense of numbers and patterns. Statistics helps us collect, analyze, interpret, and present data in meaningful ways. In this video, we'll explore how statistics powers data science, from basic concepts to real-world application. Let's start by looking at what statistics really means and why it's the backbone of every data-driven decision. Statistics is more than just numbers. It's a branch of mathematics that deals with collecting, organizing, analyzing, and interpreting data. In data science, statistics provides the tools and techniques to make sense of large datasets, identify trends, and draw conclusions. Without statistics, data would just be a collection of random numbers with no real meaning. By applying statistical methods, we can uncover patterns, relationships, and insights that drive business and scientific decision. Data science, statistics is the engine behind every analysis. It helps us understand data distributions, measure variability, and test hypotheses. Whether you're building predictive models or visualizing data, statistical thinking ensures your results are reliable and valid. Data scientists rely on statistics to make informed decisions, avoid biases, and validate their findings. This makes statistics an indispensable part of the data science toolkit. Descriptive statistics is the first step in data analysis. It involves summarizing and organizing data so we can understand its main features. Measures like mean, median, mode, and standard deviation help us describe the central tendency and spread of data. In data science, descriptive statistics are used to get a quick overview of the dataset before diving deeper. This step is crucial for identifying outliers, trends, and patterns. Inferential statistics takes things a step further. Instead of just describing data, it allows us to make predictions and generalizations about a larger population based on a sample. Techniques like hypothesis testing, confidence intervals, and regression analysis are key tools. In data science, inferential statistics helps us draw meaningful conclusions and make data-driven decisions, even when we can't measure everything directly. Quality of your analysis depends on how you collect your data. Statistics provides guidelines for designing surveys, experiments, and observational studies. Proper data collection ensures that the results are accurate and unbiased. In data science, understanding sampling methods and data sources is critical for building trustworthy models and analyses. Good data collection is the foundation of any successful data science project. Sampling is a core concept in statistics. Since it's often impossible to analyze an entire population, we select a representative sample. Techniques like random sampling, stratified sampling, and cluster sampling help ensure that the sample reflects the population. In data science, proper sampling prevents bias and improves the reliability of your conclusions. It's a key step in any statistical analysis. For analysis, data must be cleaned. This means handling missing values, correcting errors, and removing duplicates. Statistics helps us identify anomalies and inconsistencies in the data. Clean data leads to more accurate analyses and better models. In data science, data cleaning is often the most time-consuming step, but it's essential for trustworthy results. Exploratory data analysis, or EDA, is where statistics shines. EDA involves visualizing and summarizing data to uncover patterns, trends, and relationships. Techniques like histograms, scatterplots, and correlation analysis help data scientists get a feel for the data. EDA is a creative process that guides further analysis and model building. Probability theory is closely linked to statistics. It helps us quantify uncertainty and make predictions about future events. In data science, probability is used in everything from risk assessment to machine learning algorithms. Understanding probability allows data scientists to model randomness and make informed decisions under uncertainty. One of the most important lessons in statistics is understanding the difference between correlation and causation. Just because two variables move together doesn't mean one causes the other. In data science, statistical tests help us determine whether relationships are real or just coincidental. This distinction is crucial for building valid models and avoiding false conclusions. Hypothesis testing is a core statistical method. It allows us to test assumptions and make decisions based on data. In data science, hypothesis tests are used to compare groups, check for differences, and validate findings. This process helps ensure that results are not due to random chance but reflect real effects in the data. Regression analysis is a powerful statistical tool for modeling relationships between variables. In data science, regression helps us predict outcomes and understand how different factors influence results. Linear regression, logistic regression, and other techniques are widely used in predictive modeling and forecasting. Statistical significance tells us whether our findings are likely to be real or just due to chance. In data science, we use p-values and confidence intervals to assess significance. This helps us avoid making decisions based on random noise and ensures our conclusions are robust. Data visualization is where statistics meets art. By turning numbers into charts and graphs, we can communicate complex ideas clearly and effectively. In data science, visualization tools help us spot trends, compare groups, and share insights with others. Good visualizations make data accessible and actionable. Statistics forms the backbone of machine learning. Algorithms like linear regression, decision trees, and clustering all rely on statistical principles. Understanding statistics helps data scientists choose the right models, tune parameters, and interpret results. Without a solid grasp of statistics, machine learning would be little more than guesswork. Feature selection is about choosing the most relevant variables for your model. Statistics provides methods like correlation analysis and variance thresholding to identify which features matter most. In data science, selecting the right features improves model accuracy and reduces complexity. Evaluating models is a statistical process. Metrics like accuracy, precision, recall, and F1 score help us measure how well our models perform. In data science, statistical evaluation ensures that models are reliable and generalize well to new data. This step is critical for building trustworthy solutions. Bias and variance are key statistical concepts in data science. Bias refers to errors from incorrect assumptions, while variance measures sensitivity to fluctuations in the data. Balancing bias and variance is essential for building models that are both accurate and robust. Understanding these concepts helps data scientists avoid overfitting and underfitting. Overfitting happens when a model learns the noise in the training data instead of the underlying pattern. Underfitting occurs when a model is too simple to capture the data's complexity. Statistics helps us detect and prevent both issues, ensuring our models perform well on new, unseen data. A/B testing is a statistical method for comparing two versions of something to see which performs better. In data science, A/B tests are used to optimize websites, products, and marketing campaigns. By applying statistical analysis, we can make data-driven decisions that improve outcomes. Time series analysis is about studying data points collected over time. Statistics provides tools to analyze trends, seasonality, and cycles in time-based data. In data science, time series analysis is used in forecasting, stock market prediction, and monitoring changes over time. Anomaly detection is the process of identifying unusual patterns or outliers in data. Statistics helps us define what's normal and flag anything that deviates from the norm. In data science, anomaly detection is used in fraud detection, network security, and quality control. Clustering is a statistical method for grouping similar data points together. In data science, clustering algorithms like k-means and hierarchical clustering help us discover natural groupings in data. This technique is widely used in customer segmentation, image analysis, and pattern recognition. Dimensionality reduction is about simplifying data by reducing the number of variables. Statistics provides techniques like principal component analysis (PCA) to retain the most important information while eliminating redundancy. In data science, this makes models faster and easier to interpret. Modern data science relies on statistical software like R, Python, and SAS. These tools make it easy to apply statistical methods to large datasets, visualize results, and automate analyses. Knowing how to use statistical software is a must-have skill for any data scientist. Big data presents unique statistical challenges. With massive datasets, traditional methods may not scale or work as expected. Statistics helps data scientists develop new techniques for sampling, analysis, and visualization that can handle the volume, velocity, and variety of big data. Ethics is a critical aspect of statistics in data science. Data scientists must ensure their analyses are fair, transparent, and respect privacy. Statistical methods help identify and prevent biases, ensuring that data-driven decisions are ethical and responsible. Communicating statistical results is just as important as the analysis itself. Data scientists use clear language, visualizations, and summaries to share findings with stakeholders. Good communication ensures that insights are understood and acted upon. Statistics is a constantly evolving field. New methods, tools, and best practices are always emerging. Data scientists must stay up to date with the latest developments to remain effective. Continuous learning is key to mastering statistics and succeeding in data science. Statistics is used in countless real-world applications from healthcare and finance to marketing and sports. In data science, statistical methods help solve practical problems, improve processes, and drive innovation. The impact of statistics can be seen in every industry. In healthcare, statistics is used to analyze patient data, track disease outbreaks, and evaluate treatments. Data scientists apply statistical models to predict patient outcomes and optimize care. This leads to better decision-making and improved health outcomes. In finance, statistics is used for risk assessment, fraud detection, and portfolio optimization. Data scientists use statistical models to forecast market trends and make investment decisions. Accurate statistical analysis helps minimize losses and maximize returns. In marketing, statistics helps analyze customer behavior, measure campaign effectiveness, and segment audiences. Data scientists use statistical techniques to personalize offers and improve targeting. This leads to higher engagement and better results. Statistics is revolutionizing sports. Data scientists analyze player performance, optimize strategies, and predict outcomes using statistical models. This data-driven approach helps teams gain a competitive edge and make smarter decisions on and off the field. In e-commerce, statistics is used to analyze sales data, optimize pricing, and recommend products. Data scientists use statistical models to understand customer preferences and improve the shopping experience. This leads to increased sales and customer satisfaction. Statistics plays a big role in social media analytics. Data scientists analyze user engagement, track trends, and measure campaign impact using statistical methods. This helps brands connect with their audience and improve their online presence. In transportation, statistics is used to optimize routes, reduce delays, and improve safety. Data scientists analyze traffic data and predict demand using statistical models. This leads to more efficient and reliable transportation systems. Statistics is vital in environmental science. Data scientists use statistical methods to monitor pollution, track climate change, and manage resources. This data-driven approach helps protect the environment and promote sustainability. Statistical analysis isn't always easy. Data scientists face challenges like missing data, noisy measurements, and complex relationships. Overcoming these challenges requires a solid understanding of statistical methods and creative problem-solving skills. The future of data science is closely tied to advances in statistics. As data grows in size and complexity, new statistical methods and technologies will continue to emerge. Data scientists who master statistics will be well equipped to tackle tomorrow's challenges and drive innovation. There are many resources available for learning statistics, from online courses and textbooks to tutorials and communities. Data scientists should take advantage of these resources to build a strong statistical foundation and stay current with new developments. Developing statistical intuition is about more than memorizing formulas. It's about understanding concepts deeply and knowing when and how to apply them. Data scientists with strong intuition can spot issues, ask the right questions, and make better decisions. Data science is a team effort. Statisticians, analysts, engineers, and domain experts work together to solve problems. Good communication and collaboration ensure that statistical methods are applied correctly and that results are meaningful. To sum up, statistics is the heart of data science. It transforms raw data into actionable insights, guides decision-making, and drives innovation across industries. By mastering statistics, data scientists unlock the full potential of data and shape the future. Thanks for joining us on this journey through the importance of statistics in data science.